So the only way I can get the fan to turn on is if I push in the...
No, don't push it. Don't push it in now. So hold on. You would push that in with your finger?
You just push it in and then the fan would start. Wow.
Done. Timer flashed 7 times. BTU system.
You ain't testing, you're guessing.
What's going on, ladies and gentlemen? Thank you so much for tuning in. It's me, Mikey Pipes. Today is Monday, June 26th, 2023. I just got on the Wyck Expressway yet again. If you're from the New York metropolitan area, you know you got to do the exit ramp and the the service road shuffle to get anywhere, especially if you're going northbound on the Wyck. Like what I'm doing right now is completely legit. You gotta cut people off here. See, you gotta do moves like that. If you don't do moves like that here in New York, well, you might as well go to Florida. Anyway, quarter to 8 o'clock in the morning. Yep. And I'm going to Kew Gardens. I have a new client, a new caller, should I say, that is a YouTube subscriber. He's been emailing me back and forth for at least a week now about his air conditioning, his central air conditioning not working, and I guess it's not a priority for him or his schedule is busy, but nonetheless, we made an appointment finally for this morning, 8 o'clock, and I rescheduled another job because I wanted to get him done first and complete my loop. I'm starting in Kew Gardens, then I'm going to Great Neck, then I'm going to Manhasset, and then I'm going to finish up in the Five Towns near the shop in Woodmere. So nice easy loop. We have 4 service calls scheduled for today, and there's Jamaica Hospital right there. There's my Waze. Man, crazy, bro, crazy. So let's get over to the this right lane right here. And yes, I crossed a solid line. This is New York, ladies and gentlemen. Stop signs are optional. Slightly tap on pedal, bro. All right, let's go see what's going on. Smash that thumbs up button in advance. Do it now.
And then they left.
Gotcha.
Oh, we got to go pick up a part, and they never came back. Thank God I didn't pay him anything.
All right, ladies and gentlemen, we're here at our 8 a.m. service call, 7:58 in the morning. We're already on the air handler located in the basement. Thank God it's in the basement. And look, they actually used pokey to seal all the joints in the ductwork. Very nice. Why they did a return like that? Anyway, it's been a long time since I saw voltage like this. We have 209.5 volts, where you normally have 220, 240 volts. I came down here because my transformer, or my voltage between R and C, or R and G, or R and Y, or R, going at my thermostat was only 24 volts, when normally you see 28 volts. And this kind of explains it. We're 209.8, and it's fluctuating a little bit. Interesting. Homeowner happens to be quite chatty. It's okay, though. He had, when he first bought the house, he had the service upgraded from 100 amps to 200 amps. And then recently a truck hit a pole or something like that. Did I hear you correct? And
They stalled outside.
What?
The truck just broke down outside the house.
But it hit the pole?
It didn't, no.
I thought you said hit a pole and reversed the wires.
No, that was the guy when...
That was the electrician.
Yeah, the guys who came to look.
Gotcha. Okay, so we have 208.9 volts now. See, 209. Wow, it's moving around a little bit, actually. It's weird. Let's, New York City, go for your Con Ed. You pay your Con Ed bill? I take that as a yes. All right, let's see what kind of voltage we have leaving our wiring here. But before we actually check that, let's do something else. Let's do L1 to a ground. Right, that's ground, and we have 120. Let's do the other one there. Right? And we also have 120. He has something funky going on with his voltage, because 120 and 120 doesn't equal 209. I'll tell you that. 120 plus 120 does not equal 209. All right, before we get started on that, here is our 24 volts going to our stat. The brown wire is normally common, right? Brown is common. Our gray is fan, right? Gray, G, fan, right? But common and gray are together here for some unknown reason. And that's no bueno. I'm surprised that fuse is good. Was that an Amazon Chinesium fuse?
Home Depot.
Home Depot fuse. It's probably not Chinesium, but it may be though. So the first mistake here is that let's turn the power off actually. First mistake here that we have here is that our common and our brown are together. That means every time we have a call for heat, or anytime we have a call for cooling or call for fan, R is going to travel through back to G and then blow out the fuse because it's uncommon. I swear you can't make this stuff up. Okay, so let's just disconnect everything and start over. All right, I'm not scared to start over. We have a lot of wires here. We have, this is going to be some kind of, looks like some kind of float switch. Where is this going? Don't know for now. Oh, why did that just come out? All right, let's fix the wire. All right, so my wire nuts on my line voltage L1 or L2 are coming out, so I use the Wago couplings, the lever connector 221s. That's not going anywhere. It's better than a wire nut. I have my Fluke multimeter test leads on R and C. R on the right, C on the left. And let's see what happens when we turn it on. Well, it was on. You normally hear a hum from the transformer. We have no hum. And we have 24 volts. Interesting. Let's see if we do red to gray. I'm gonna turn the fan on. All right, so we're jumping out R and G. So there's blower. There's blower with 24 volts. So our blower is good. That's a good thing because that's an ECM motor. That's expensive to replace. Now we're gonna figure out our wiring. All right, that looks like Chinese. You think that looks like Chinese to you? Doesn't, right?
Chinese or Japanese.
Something kind of Oriental.
Yeah.
Maybe Korean?
No,
not Korean?
That's too artsy.
That's too artsy, right? The Koreans are not that artsy.
They're more block.
No, not. Samsung is great TVs, though. That's an artsy TV, but I love Samsung. All right, so I wasn't paying attention to when I removed all the wiring. I believe this is thermostat, and this is some kind of float switch. It has to be. But I set my multimeter to read resistance, and I want to check resistance and see maybe this line is our contactor. And I would safe to say it is. Reading 19.3 ohms. This is going to be our contactor. And we can easily check that by giving this power, R and C, and see if the contactor pulls in. But we'll save that for later. This is going to be our thermostat. So we have red, white, and blue. Let's go see what's upstairs. All right, so I know this is my thermostat. This is that extra wire. Now, I set my voltmeter to read continuity. And if I touch the two wires together that look like this behind the thermostat, I make noise, so I have continuity. So there's my extra set of wires, which I don't really think I need. Here is R, Y, and G. I guess we can make one of those common if we wanted to. And here is condenser. So let's wire this. Okay, so let me show you. This is very easy. Very, very easy. We have 3 wires leaving our air handler. We have red, which is 24 volts. We have brown, which is common, that neutral. We have gray, which controls fan. You're going to notice that we do not have a wire for cooling because it doesn't need to be here. This is a single stage system. If there was Y1, Y2, or multiple fan speeds, then yeah, maybe we'd have that. So our red, which is our 24 volts, is going to go to RC. Now, when there's a call for fan, RC power, which is 24 volts, will go to the gray wire, and that will turn the fan on like we did earlier, right? So the I made the white wire green, which goes to gray. And the blue wire is our cooling circuit. That's going to go to one of the two conductors going to the outdoor condensing unit. One is for Y, and the other one is going to be common there. If I wanted to bring common to the thermostat, you know, for Wi-Fi functionality or not use the batteries, I could use one of these wires, right? And let's take the black wire, we'll make that common. And I did that by replacing the 2-conductor Wago connector with a 3-conductor. So here's common. Here's that common going to my outdoor condenser. And the black wire we're going to repurpose as common going to our thermostat. So now that that's all together, let's go to the thermostat, put that back in the wall, and wire that up properly. All right, so here's our thermostat wires. This white and this red, well, that's to our... That is to our boiler. And if we go like this real quick, you can hear it clicking. So that's our boiler. And the black is going to be our common to our thermostat. All right, all of my wiring is connected. R, H, and W. That's for our cooling circuit. And all the other ones for, heating circuit, all the other ones for cooling circuit. I took the batteries out. You want to turn that switch on next to the air handler? And we'll see if this thing powers on. Smash that thumbs up button, guys. Come on, baby. Honeywell, there you go, baby. That's right. That's right. So now let's do fan. Let's check our fan functionality. Okay, give that a minute. Fan is on. Good. Let's see if that fan comes on. Hear the fan? Interesting. No fan?
No.
No fan.
The fan outside, the condenser outside is on.
You hear the fan outside on right now?
The refrigerator.
Oh, interesting. Our white. Did I reverse it? Yeah, I did reverse it. The blue is my fan. Oops. All right, so now my blue is G, white is yellow. Okay, take 2. All right, take 2. Okay, Honeywell's on, fan is on. All right, before we head outside, let's make sure they all remember who the hack wasn't. So every time you're practicing, here and there, you're gonna know that the reason why you're cool, you called Mikey Pipes. All right, here we are at the outdoor unit. The homeowner did tell me that he replaced the dual capacitor himself, so let's take a look at that wiring. The terminal on top marked C, that's common, and that has 4 terminals, which it typically does, and that's going from, we'll call that T2. Herm is our blue wire, and that has 3 terminals, which is typical. And our fan normally has 2 terminals, it only has 1 in this case. You must have gotten this from Home Depot? Amazon. Gotcha.
So the only way I can get the fan to turn on is if I push in the...
Don't push it. Don't push it in now. So hold on. You would push that in with your finger?
You just push it in and then the fan would start.
Wow. And the compressor?
Yes.
Wow. And you would hold that there and you have air conditioning while you're outside and the people inside are cool?
Just for a few minutes.
For a few minutes, okay. Use your finger, really? All right, no comment. We don't want OSHA to hear that. All right, so I have great news for you. You no longer have to push in the button on the contactor with your finger or a screwdriver, whatever you're using. Now you'll go to the thermostat like I would like you to do right now.
That's the idea.
And put the mode to cool and set it to a temperature so the air conditioning comes on. Sound like a plan? Excellent. Okay. Here we are, ladies and gentlemen, for the first time since his electrician has been here and wired the house from 100 amps to 200 amps, he's no longer going to have to push in the contactor to get this bad boy to work with his finger. And there it is. So how that worked, ladies and gentlemen, let me explain that to you real quick. We had 24 volts being carried by R, which goes to the RC terminal. The thermostat is actually acting like a switch. It's closing the circuit. It's closing the circuit between G, which is our fan circuit for the blower inside, and the Y cooling circuit, which Y, if you notice, there's no Y terminal on the air handler. It went directly to one of these two wires here, right? So Y is being brought into one side of our contactor relay, 24-volt coil relay, right? And the other side is common, right, which is that neutral on the transformer. So when you close that circuit at the thermostat and with a call for cooling, 24 volts, leaves R, goes to Y, comes to Y here, right, and leaves there.
Now I don't have to stand out here anymore and hold the button.
Smart. Smart, very, very smart. All right, since we have a little bit of time left over of the hour, I believe in giving my customers value, and that's how you develop and strengthen relationships. It is 8:38. We got here, what, at 7:50-ish? So he's got another 10 minutes on the clock. Let's give him his money's worth. Let's do an underload capacitor test. And that means we're gonna test the capacitor, dual capacitors in here, dynamically while the system is running. And it's very easy to do. You need a voltmeter. All right, this is the 902FC. Link down in the description box down below if you want to buy it on Amazon. I'd appreciate it. Also, all the tools that I have in my Veto TPXL, all the tools in there, including, you know, my digital manometer, my HIK micro thermal imaging camera, everything. Everything in this tool bag is down in the description box down below. So I'm using the HVAC School app. This is called the Underload Capacitor Test. And first thing we're going to do is take a voltage across the capacitor reading. So we have, there's our capacitor, and we got to take voltage across it. In case you don't know how to do that, you hit the little diagram right there, and we're going to do between common and Herm. So let's put one on Herm and another one on common. Okay, like that. We have 304.1. So let's exit out. Let's do 30. Did I say 304? No. I'm a little dyslexic today. 313.8. 313.8. And the amperage of that, so let's do that next. We're going to take our clamp on meter. We're going to put that to read amperage. And let's put that on that blue wire, right? And we have 7. Okay? So let's put that 7 there. And next is the capacitor rated value in microfarads. This looks like to be a 60. Let's put a 60 in there and hit calculate. And perfect. We're actually reading 59.18 microfarads on this 60 microfarad capacitor. So we tested the Herm side of it. Now let's test the fan side of it. So let's put that right there. Let's put that to read voltage AC. We're at 285, right? Let's do 285. And then the amperage of that, let's read that. Back here, amperage. The fan, we're reading 0.5. Okay, 0.5. And our value is a 5. And we have, oh no, it's low. We're reading 4.65 microfarads on this. So this capacitor is 5 to 10% low, which would generally be considered acceptable, but may vary by company policy. My company policy is 10%. The variation is, okay, so let's see. You're between 5 and 10%. So let me tell you what the pros and cons to keeping this capacitor in place. Now, I'm a little concerned by you saying it was brand new. And let's just double check our math before we proceed. All right, let's double check our math. We have, let's take an amperage reading of our fan, which is 0.4. Okay, and now it was 0.5 before, now it's 0.4, so it's 0.4 there. Let's take a voltage reading across those two. Still on there. We are at 284.6. 284.6. We're going to calculate, and now we're at reading 3.73. So, I know you said that the capacitor is brand new, but let me explain to you the pros and cons. Let me explain to you what will happen when the capacitor fails on the fan side. The fan will no longer get the extra oomph it needs, and for lack of better words, and not confuse you as a layperson. and the fan won't turn. The fan, which should be thermally protected, what that means is if it's overheating, it's going to turn itself off. It's going to open the circuits inside of it, still getting the power, but not doing anything with it. Preventing the internal windings of the motor from burning out. Keep that in mind. Okay, so I know you have a brand new capacitor, and our voltage is fluctuating. So now you're at 385.2. Let's just put that in there and see what that comes up with, right? 385.2. Now let's calculate that, and it's still low. So, like Cy Sims from Sims, clothing store said, an educated consumer is my best customer. Now you're educated, and now you know that the capacitor, even though it's brand new, that you put in from Amazon, when it no longer gives enough to the fan to start, the fan's not going to turn on anymore. The compressor will still run, right? Because it doesn't know the fan's not working anymore. And the same thing happens with the hermetically sealed side, the Herm side, which we tested okay, right? When that no longer does its voltage, the compressor is still going to get power, but eventually it'll go into thermal overload, and that's why we have things called the cool presser, which is this magnet with a hose attached to it, and put it right on top of the compressor, and we cool it off for 15 minutes. And we pray. Ladies and gentlemen, I'm saying it again, and I just got to say thank you. Thank you to all the hacks out there who continue to give me stacks. Hacks bring me stacks, ladies and gentlemen. Stacks. Look at this. Look at this service call. They actually told him, the homeowner, a couple weeks ago, that they need to go get a part. They left, and they never returned. Oh, thank you, hacks. Thank you so much for being there for me. I don't know what I would do without you. I really don't know what I would do without you. Thank you so much, hacks, for your hackery, your dedication to hackery. I really, really appreciate it. Ladies and gentlemen, if you want any stickers like the ones behind me that emphasize hacks bring me stacks, if you ain't testing, you're guessing. Email me, Mike@MikeyPipes.com. All right, ladies and gentlemen, thank you again from the bottom of my heart for your unconditional support to the channel. I really, really, really appreciate it. I really do. All right, so now it's 10 minutes to 9. We're heading over to our next service call, and I'll end this video now. Thank you again. Until next time, be well, God bless, stay safe.